So right here, I'm going to say definition, but pretty much we're on 446, 447 in general. The Tukey, that's Tukey, range test. Okay, the Tukey range test helps us pinpoint which pairs are significantly different. Because see, the textbook says it in a really, really academic, lofty kind of way, but I want to get straight to the gusto. Which pairs are significantly different? Okay. Now, notice that, and I'm going to actually write this down. Yeah, we only use this method when we blank H sub 0 in our ANOVA. Think about what we just said. I wonder if anybody can figure out what that word is that goes inside of there. And people have been chatting. I didn't know. Okay, all right. Think about the setup of the problem that we just said. I just showed you an example of ANOVA, right? When I did the F test, the cutoff and all this stuff. We only use this method when we blank H sub 0 in our ANOVA.
Would it be when we reject it?
Very good. Very good. Who is that? Who is that?
Lily.
Okay, very good. See, when we reject. Because see, if we accept H sub 0, that's basically saying we accept the fact that all of the groups are equal. Right? So that's good, Ashley. Right. So if, and we're going to find out something that we're going to do today. I still may have you doing the Tukey range test just for teaching purposes to see that what happens if you do it, if you accept, right? But we only are forced to go into this mode of the problem when we reject H sub 0. Okay? So there are some detailed mathematics involved. Like if you look on page 447, at the very, very bottom says Tukey defined, right? Critical range and that weird thing, square root of all that stuff. We're not going to go into all that. That's more like stuff I did like when I was in grad school, right? But this just gives a lot of the theory kind of behind it. We're going to cut straight to the gusto and use what's called a Tukey range worksheet in Excel, right? But remember, H sub 0 looks like this. Oh, I don't know. Mu Wendy's equals mu Taco Bell. Remember how we did that equals this all the way? And then H sub 1 looks like not all mu's are equal. We talked about this last time. But I don't know whether the equal sign goes here, or here, or here, or everywhere. Right? So that's the only way we can find out more details so that when we finish doing Tukey-Kramer, I will be able to write H1 in a more specific, correct form that reflects which ones are different. Okay, I just want to make sure you understand conceptually. Now, when we solve this problem, we're going to have to use something called a Q table, the letter Q. And I think I put one in the this week's folder, so you may want to grab that. When using the Tukey procedure, we use a Q table. All right. So what's going to happen? It's kind of similar to the F table, but that one value that we get when we look up in the Q table, that one value alone is not going to determine acceptance or rejection. Because what we're going to do is look at the difference between these two groups, you know, all of the groups together, and compare them to a number that involves the Q statistic. Okay? So we're going to have to use a Q value that corresponds to K. We know what K is, how many groups you have, and then K times N minus 1 for a certain alpha. And alpha, when we reject and go to this particular phase here, we're always going to use the same alpha here as we used for the original problem, the original ANOVA problem. Now, when we use F, remember F looks like this. F of K minus 1. When we look at this cutoff, remember that? When you look at that table, this is K minus 1. But here for the Q, we're just going to use how many groups we have, period, right? That K. And then we sort of know how to do this. The good thing about it is that I would never ask you to do the math regarding the Tukey procedure. You're just going to have to know how to do it in Excel. All right. So I want to. Okay. So let me stop. Any questions so far? Any questions? Yeah.
Hi. Sorry. It says Q table and then under it, does that say Q as well with the K?
Are you looking at the table that's on the
No, I'm looking at that board.
Oh yeah. So pretty much we're going to use a Q table, and when we use the Q table, we're going to use these values to figure out what number I'm going to use in Excel, and I have to show you in just a second.
Okay, so that says Q.
Yeah, this is a Q and then like a K.
Okay.
A small K, comma, K times N minus 1, and then comma, and then alpha.
Thank you.
All right. Okay, so let's go back to our original problem. With Wendy's, Taco Bell, because that's a good candidate for this, because I think we rejected. Yeah, we ended up rejecting. We rejected. So here's what you're going to need. You're going to need the results that we just got from using the tool pack. Let me show you. You're going to need to look at this. Okay, so get that handy. And you're also going to need a Tukey Kramer worksheet. See if I put it in this week's folder. It should say Tukey One Way or something like that. Tukey One Way. You're going to need that as well. And I think it looks like this. Let me open it up. You should be able to download it like to your laptop or something, like your desktop or something. I want to show you how to use that. Let me show you what it looks like. Woo. I'm gonna have to get a job with a tech company after this. All this stuff. Okay, let me see here. Save this. So you're gonna need to look at both of those at the same time. ANOVA. Let me save this. Okay, I'm gonna stop sharing this. And then I'm gonna start sharing this. Are you guys able to see that? Are you able to find that in the week's folder?
Yeah, we have that in our folder.
Okay, great. All right. So look at, because see, you're only going to be able to fill out this Tukey worksheet by looking at the results from the ANOVA. Okay, so you're gonna have to look at both of those at the same time. And let's share my screen so you can see. Yeah.
Do you think it's possible for us to just somehow copy and paste the results from the ANOVA into that sheet, because it's kind of difficult to have the collaborate and two things open at once.
Okay, that's good. See if you can do that. That may be a good idea. In other words, the results that you see for ANOVA, put it somewhere on the Tukey sheet. That might work. Try that. Yeah, because I guess it really could pull on your, but the thing is, you got to make sure you're on the right Tukey sheet. And so if you want to, you can go ahead and copy it, and then before you paste it, let me show you where to paste it. Let me show you where to paste it.
All right.
Okay, so if everybody take a look at this right here, just for right now, the Tukey sheet. You see at the bottom it says TK3, TK4, TK5, right? The very bottom. What we need to make sure we're doing prior to your pasting is make sure you're on the right sheet, right? And how do I know if I'm on a TK3 or TK4? It just basically, what is your K in the problem, right? So in this drive-through problem, what is our K? What is our K? I think it's 4. Wendy, how many groups do we have? Do we have 4 groups?
Yeah, it's 4.
Okay, so for this problem, just click on TK4. Now you can paste the results on here somewhere, right? So, and in other words, you have to make sure you're on the right sheet, right? So, what's determined as to which sheet you're going to use in Tukey is the size of your K. I think for the quiz, I think the K was 3. Then you have to click on like a K3. So just make sure you're on the right formula there. And then from here, go ahead and post the solutions from the one way. Yes, question?
Is it like, are we posting the one that we did, like we're posting the data from the tool pack extension, correct?
Yeah, from the drive-through.
Yes, okay.
Yeah, it's the one that's showing all of the information there. The F test.
Yeah. The one that we did like the extension with. That data. Okay, thank you.
And so you don't have to necessarily put the data itself. You can just put the results. The results were saying 8888, right? So I'm gonna put it here and let me show you. I hope this works. Okay, yeah. So let me share. Oh, okay. You should see it. You guys see what I just did? I took the results as I forgot who suggested that, but just like students suggested, I just cut and paste the results from my one-way ANOVA onto the TK4. That's actually was probably a really good suggestion. So I guess now if you want to, and I'm really scared to do it, I was going to close out this ANOVA sheet there, but I would hate to do that, and it erases this. I don't know. It should be fine, but okay. Is everybody at least with me in terms of this Tukey Kramer sheet? Do you guys understand what I just did when we copied this information onto here? Because I have to use the information from the ANOVA single factor to help me with this Tukey thing. Okay, let's go ahead and you're gonna have to listen to me because I guess you can see me, but everywhere there's green, I gotta put something inside on this Tukey sheet. Treatment name. Those are gonna be the names of the groups. So let's put in Wendy's. You have to put them in the right order. It should be right here. Wendy's, Burger King, Taco Bell. Oops, Taco Bell. Taco Bell. McDonald's. So all those go under treatment. McDonald's. Okay, it's just telling you what your groups are. Now sample mean. All of these are 888, so 8. Oops, I'm sorry. That's sample size. Sample size is 8. Okay, so we're here sample size, that's our N. 8, 8, 8, 8. And you see over in the right, it's filling in some information on the right, in the green on the right. Eventually, that's where it's going to give us our final answer. And I probably should have made those a different color, but you know, for example, let me show you something. Yeah, so all these right here, I don't know if you can see that. It's going to eventually tell us the right answers over here, right? All right, let's keep going. Sample mean. I need to type in these values right here. Average. See, those are my X bars. So maybe you can cut and paste. I don't know. It may work. 150.125. And make sure you do the right ones for the right group. 158.75. All right. We'll come back to these in a minute because this is going to give us the final result. Now we need to fill in these over here, then we're done. Now degrees of freedom denominator is always going to be, so let's go back to our ANOVA results. What's our ANOVA results? Now notice here, this value right here is K. That's, you know, that's always going to be given when you choose the right worksheet. That's already going to be filled in. Degrees of freedom denominator is K times N minus 1, and that should be this number right here, the 28. K is 4, our N is 8, so 4 times 7, yeah, 28. So you can just type that there. That's always going to come from there. So I don't know if you need to make a note of that, but it's degrees of freedom within group columns is always going to be this number right here. That's going to go right there. Okay, MSW, mean squared within, is going to go from here, mean squared. You see this MS within, so it's this number right here. So you can cut and paste that. Well, it took away the green, but that's okay. That's okay. If you want to type it in there, that's fine. I don't care. But again, let's go back here. Degrees of freedom denominator is this number right here, 28, and the MSW is the number right beside it. Now this Q crit is what we're going to have to get from the table, the Q table itself. So everybody get your Q table. Get your Q table. I think I put one in the folder, but if you have, let's see, the regular textbook, it's on page 657. 657 in the textbook. But either one should work. Either one should work. So let me come back here. I'm going to show you. Did I even put the Q? Yeah, I didn't load the Q table to show you. But everybody grab your Q table. Remember, the Q table comes from here. See, look here. If you can see it. I need to go to the Q table. I need to make sure I'm on the right alpha level. 0.05 or 0.01. Yeah.
Can you please repeat the page that the table is on in the textbook?
Yes. 657. 657. All the way in the back. Now, go to the right. See, it's two sides of it. And I think the one I posted, I think it gives like two numbers for alpha, whatever. But we want to go to alpha 0.05. Now, I want to go over to the right, K units. In our problem, the K is 4. Wendy's, Taco Bell, blah, 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 blah. And this value here is 4 times N minus 1. What's our N? Is it 8? I think it's 8. And then alpha equals 0.05. What is this right here? Is that the 28? I think that's the 28. Okay, so go over 4, down 28. Okay, so there's no 28 on here, so what we have to do is choose the one that's closest. On the chart that I posted in this week's folder, I didn't take a look at that. Does that have a 28 on it or no?
No, 24 and 30.
Oh, okay, so it's the same as that one here. Okay, so just choose the one that's closest, and if it's equidistant, then I don't care which one you choose, right? It's not going to affect the results that much. So if I do that, what would have to be my Q value that I'm going to have to eventually use? Question?
So if that happens where we have to, it's equidistant and we have to choose one or the other, should we just like make a note and tell you that like our number wasn't on the chart, I used that?
Nah, I'll be able to figure out because what's going to happen is at the end of the day, it's probably still, it's not going to affect the final answer. All right.
Okay, all right.
So choose either one. But in this case, though, I'm probably going to have to use which, what Q value am I going to have to use at the end of the day here? If I choose one that's this.
30?
Right, and so then
There's
what's my final?
I have a question.
Mm-hmm.
So for the table, since we have to go over 4, we would be landing on 5, right?
No.
Or
Why
we would
you
have to, huh?
No, Why would you land on 5? Are you thinking K minus 1?
No, I'm thinking, okay, so I see that we got 4, but when we do the F table, we have to go over that number. So like,
Okay. Well, see, remember, it's 2 separate tables. Because, see, this F table I'm only using for when I'm doing ANOVA, right? And then that would be K minus 1, where in this case, it would end up being 3, right? But in this case here, I'm actually, see, I'm not using K minus 1. I'm using actual K right here when I get to the Q table.
okay, I mean, I guess my question is like when we get K minus 1 for F, you said that we have to go over however many numbers, so we would land on 3. But
Yeah.
for this one, we just use the exact value then.
Yes, yeah, exactly.
Okay,
Yeah.
thank you.
Yeah. So once you get to that Q situation where you ended up rejecting X 0, then I have to put a 4 here instead of that 3. It would be a 3 over there. Okay, so let's see. My Q value I'm going to use is, anybody see it? What's my final Q statistic that I'm going to use according to the table? Good, Jubilee. Good. So I go over 4, down 28. Well, it's closer to 30. So do you see where it intersects at 3.85? See that? 3.85. Let me write it right here. Does everybody see that? You see that? See, I went over K and down K times n minus 1 in theory, right? So if I end up at 30, that should intersect at 3.85, which is this value here, which is the last value that I have to put inside of the Tukey Kramer sheet. Yes.
So I'm using the one on like that you did on Blackboard because it's just easier for me to like do it on my computer. And when I go to 4 and then down, like it gives me in the little box, it gives me 2 numbers. Like it's 3.85 and then below it is 4.80. So would we choose the top number 3.85 because like 28 is closer to like higher 30?
So you will use that 3.85, but for a different reason.
Okay.
It's giving you the answer. I think the top answer is alpha equals 0.05, and the bottom number is alpha equals 0.01.
Okay.
But just check at the very top because it should tell you like at the top like some kind of guide.
Oh, okay, yeah, the top is 0.05 and the bottom is 0.01. Sorry about
Okay, good. Okay, good. Yeah, very good. Yeah.
Thank you.
All right, so everybody go ahead and type in 3.85, 3.85, in that last green portion of the Tukey Kramer. Type in that last thing. But notice here that you're only going to be able to do this if you know how to read the Q table. Okay, so we put the 3.85 right there, and the only value that came from the Q table. Everything else came from this. All right, what's the punchline? Go back up. What's the punchline? This is the punchline right here. And again, I should have had those in different colors. But this is telling you what the answer is in terms of your H1, right? So let's look at the first thing. It says means are different. Who thinks you can interpret that in light of this problem? Here's a clue. Look here and look here. What is that saying? What is that saying?
Wendy's and Burger King, they have significantly different, drive-through speeds.
Yes, very good, very good. Okay, how about this one? How about this one? What is this saying? What is this saying?
That Wendy's and Taco Bell also have significantly different drive-through speeds.
And how are you knowing this Wendy's and Taco Bell, for example, in this one?
Because on the left under treatment, treatment number 1 is Wendy's and treatment number 3 is Taco Bell.
Very good, very good, very good. Okay, so I'm going to show you the last thing to do, how you solve this problem, and we're going to write on the board. This is good. This is good. So I'm going to do this. This is the last thing you have to do for Tukey Kramer. I hope you would be able to tell me something like this. H1. So now I can't just say not all mu's are equal or something like that, how we wrote it. Now what I expect to see is a more specific, concrete rendering of which pairs are different. So I'll have to do something like this. The first one, Wendy's and Burger King. So I have mu Wendy's is not equal to mu Burger King. So that's the first one. You say it means are different, that means not equal, right? 1 and 2, Wendy's, Burger King. Now, mu Wendy's is also not equal to mu Taco Bell. So I have to go through each one of these pairs, So I need to be able to see 1, 2, 3, 4, 5, 6 different renderings of the answer here. So if everybody continue writing the solution. Means are different, 1 and 4. Mu Wendy's not equal to mu McDonald's. Means are different, 2 and 3. Okay, so Burger King is not equal to Taco Bell. Means are the same, 2 and 4. Mu Burger King, see, I have to keep that equal right there, because according to this, 2 and 4 are the same, Burger King and McDonald's. And then finally, 3 and 4 are also the same, mu Taco Bell and mu McDonald's. Okay, so the Tukey Kramer procedure now starts looking at pairs, and now I'm able to see which ones are significantly different and which ones are the same. Yeah.
So for the last two, it says the means are the same, but it's not the exact value. Is it just that they're close?
Yeah. So it just means that the actual difference between the two X bars, like whatever X bar was in the first, like Taco Bell, 162 minus whatever McDonald's was, it's saying that that absolute difference when compared to what's called a Tukey range or a critical range is it either exceeds it or it's still within that range. If it's still within that range, if it's like, I guess, kind of, if it doesn't veer too far from it, if it's like inside of the range, then it's pretty much saying it's the same. But if the absolute difference kind of exceeds that critical range, that's when we're saying they're different.
So would you say, because under absolute difference, obviously it has like the values, would you say that like past, let's say like 10, that would mean that they are different?
Not necessarily, because you see beside the absolute difference where it says critical difference.
Mm-hmm.
So that critical difference is the judging criteria, right? So what I'm really doing is comparing this 20 to this 8.8, the 32 to 8.8, right? The 28 to the 8.8. So that critical range that you see involves that Q statistic that we were talking about.
Okay.
So I mean, I'm not going to require you guys to know all those details, right? That's just a lot of math. It goes back to one of the pages where you saw something like Q and then square root of MSW and all that stuff. Yeah, I'm not going to require that. That's too much. That's too much, right? But just focus your eyesight on the verdict. Means are different. Means are the same, right? So I would expect you guys to know how to show this, right, and where it comes from, which comes from using the Tukey formula there.